lesson on combining and optimizing equations. Let's recap some things we should know. First of all, this point is called a local minimum or minimum value. Remember, when we put tangent lines, they have a negative slope, so we see the derivative is a negative value before the minimum point. At the minimum point, the tangent line is horizontal, so the slope is 0, so the derivative is 0. And after the minimum point, the tangent line is positive, which means it has a positive slope. The derivative is positive. It's the opposite for a point when it's a maximum point. So that's a maximum point. Here we have a tangent line that's with a positive slope. Here we have the tangent line at the maximum point, which is a horizontal line with slope of 0. And the tangent lines after the maximum point have a negative slope or negative derivative. All right, let's take some notes. Please use the paper that has been provided to you. Here's the first problem. We're given the area formula. Area equals base times height. And it says it's subject to the constraint b minus h equals 7. A, use the constraint to express b in terms of h. What that means is, well, it says use the constraint, so we're going to use this equation, the constraint one, and we want to write b in terms of h. That means you want b to be isolated and everything else on the other side of the equation. So we're going to take the b equation and we're going to move the h over by adding h to that side. So we have positive h plus 7 over here. And we have written it now with b in terms of h. B says express a in terms of h. So now we look at this area formula and we want to write it in terms of h. That means the only variable that should be on this right side is h. That means in terms of h. So we want to get rid of the b variable. Well, we have this b formula we just solved here, so we can substitute that in. So let's begin with this formula. We want this to be in terms of h. So let's get rid of this b by substituting this h plus 7, because that is b. So we've replaced this with h plus 7, and now we have a in terms of h. You can leave it like that or multiply one step further to get this. Okay, so now you try this one. We have v equals 3xt, and it's subject to the constraint x plus t equals 10. And you're going to follow similar steps as in the first problem. Try it now. Okay, hopefully at first it says use the constraint to express x in terms of t. Well, we have x plus t, we want to move that t over to the other side. So we have x equals 10 minus t. Now it's x in terms of t. B says express v in terms of t, so we have this equation. We want it in terms of t, so we don't want this x variable here, we just want t to be the only variable. So let's replace this x with what we have here. So I've rewritten it, the x has been substituted with 10 minus t, and now we have v in terms of t, it's the only variable here. You can multiply through a couple steps to get you there. Next one, give this one a try as well. Right, A says express the constraint y in terms of x. So we have this constraint equation here. We want it to be y in terms of x. So y equals something. So here's the original. Let's move this 2x over to the other side, minus 2x. And now we have y in terms of x. B says express p in terms of x. So this equation here, we want it to be expressed in terms of x. Right now it is p in terms of x and y. So we want the y to disappear and only x to be our one variable here. We're going to take this y and replace it with what we have for y here. So I've replaced that y with all of that. And now it is p in terms of x, because x is the only variable here. You can multiply this to take it one step further. Number 4, we have r, that equation, and there's a constraint of this. Please give it a try. This one says express r in terms of r. Okay, so capital R in terms of little r. So we have the big R here, and here's the little r. If we want this equation to be rewritten with just big R here and little r here, we need the n to disappear. So then we look at this one and we say, well, if we can solve this one for n, then we can substitute that in for that n to get rid of that n. So here's this n equation. We're going to solve for n by moving the r to this side. Now we take the r equation. We want this to be in terms of r, so we want this n to disappear. So we're going to substitute this into here. There, I've replaced n with r plus 25. And you can multiply this further if you want. On the other side, it says express r in terms of n. So it's the same thing here, except for the one it wants it to be in terms of is not r anymore, it's now n. All right, so if you want this rewritten in terms of n, then you need the r to be replaced. So you take this equation, the constraint one, and you solve for r. So here's the constraint equation. Now I solved for r by moving this r to that side and that 25 to that side. So r equals n minus 25. Now I take my r equation. We want this to be expressed in terms of n, so we want no r variable here. Take this value you solved for r and substitute it in here for r. So that r has been replaced with that. Always use the parentheses, and we have squared here. You can multiply this further or leave it as it is. Right now they're going to start getting a little bit tougher. Please give number 5 a try. So it says in A, express L in terms of M. So here's our L equation. We want it in terms of M, so we want the M to remain, but we don't want the other variable X. So when we look at our constraint, we need to solve this for X so that we can substitute it in for this X. So let's begin with the constraint equation. Solving this for X, well, first I'm going to get rid of this half, and I can multiply this side by 2 to make the half cancel. And I'll multiply this side by 2 as well. So the half is gone. I'm left with x plus 5m, and this was multiplied by 2 to make 100. Now I'm going to solve for x by moving the 5m to this side. So 100 minus 5m. X equals 100 minus 5m. Now we take our L equation. We want this to be, again, in terms of m. So we want this to be rewritten with only L in terms of m. So replace this x with what we just found here. So this x will be replaced with all of this. So there it is, rewritten. And we have in here m plus x, but now we have m plus this, which is x. This one can definitely be simplified a little bit. We're going to combine some things here. M and minus 5m is negative 4m. And this can be taken further even by multiplying. I can't remember if I did that. Nope, didn't do that. On this side, we have express L in terms of x. So again, we want the L equation, but this time in terms of x. So we want the m variable to disappear. So we're going to take our constraint and solve for m. So there's our constraint equation. Do the same step as before, multiply both sides by 2 to get this. This time we're solving for m. So I'm going to do minus x on this side. 5m equals 100 minus x. Now we're going to divide by 5 to get this m to be isolated. So divide this by 5 and then divide this entire side by 5 right here. Now we're going to go back to the original equation, the L one. We want this to be L in terms of x. So we want x to remain and L, no m. So replace both of these m's with this. So it's going to become the big here. There it is. 2 times this, which is m, parentheses again, and m plus x. So there's m here plus x. Let's leave it like that. This is what would be a little bit cumbersome to combine. Number 6, give this one a try. Okay, so A says express V in terms of R. Here's our V equation. It needs to be in terms of R. So we need this H variable to disappear. Don't let the pi confuse you. Pi is just a number. So imagine this was a number like 3. It would just be a number that remains. All we want to get rid of is the H variable. So here's our constraint equation. So let's begin with that one. Again, we want the H to disappear because we want V in terms of R. So let's solve this for H. So we can substitute it in. So H equals 17 minus 2R. That 2R was moved to this side. Now we have this. We go back to our V equation. We want this to be in terms of R. So we want V in terms of R. Get rid of the H by substituting this in for H. So there's the beginning, pi r squared, and the H has been replaced with that. this can be multiplied further. All right, so now v in terms of h. All right, so we want this v1, but we want the h to remain, and we want the r to be replaced this time. So again, begin with the constraint equation. We're going to solve for r this time because we want the h to remain. So 2r equals 17 minus h. Now we're going to divide by 2. So r equals 17 minus h over 2. Now we have that value for r. Let's go back to our original v equation. We want it to be in terms of h. That means h must remain, r must disappear. Here's r. Replace this r inside the r squared with this value. So pi r, all of this squared times h. All of that has been replaced. All right. Part 2. Now we're going to move on from, that was practice combining equations. And that's like working with simultaneous equations. Now we're going to look at something called optimizing. Okay, to optimize means to find an optimal value. All right, that makes sense. Optimal values. So what are optimal values? They are basically maximum or minimum values. So we learned in these last few days how to find maximum or minimum values. Here are the places where the derivative is 0 because the tangent line has no slope. It's a horizontal tangent line. So we're going to be looking for those points. Those are called optimal points. Here's a question. We have these two equations. They're both in the variables x and c. It says express y in terms of x. So this first one, we want to rewrite it in terms of x. So we're going to get rid of this c. We're going to use this second equation to help us get rid of it. So let's do that. Here's our second equation. We need this c to disappear. So let's solve this one for c. I moved 2c to that side and 3 to this side. I'm going to divide by 2. So divide all this by 2. 12 by 2 is 6. I can rewrite that like that. Divide is 3 over 2. We'll leave it like that. Now we take our y equation. We want it to be in terms of x. So we want y in terms of x. We want that c to disappear. Let's take this. We found c is all this. We'll replace that c with all of that. So there's the y equation rewritten with the c has been replaced with what it is. And it is y in terms of x. B says use differentiation to find dy dx. So now we're going to take this function and take the derivative. So dy dx is that. Let's take a look at that. That 2 dropped down, made a 10. This x has a power of 1. That 1 drops down, makes and then the x is gone. So 10x plus 6. And this number is gone, right? 10x plus 6. C says, hence, find the minimum value of y. Okay, so we have this function. The minimum point exists where the tangent line is horizontal. And when the tangent line is horizontal, it has no slope. So we're going to make the derivative equal to 0, 0 slope. So that derivative became 0, equals this, the derivative function. Let's solve that. 10x equals negative 6. Negative 0.6. And now in D, it says find the value of C that corresponds to this minimum value. So now we take our equation here for C, or plug in the x value we have into there, or in the, what did I do here? Oh no, wait, hence find the minimum value of y first. So we take the y equation, this one here, we plug in the x value we just found into it, and we find out that y is negative 3.3. Then the last step is to find the value of c. So now we take the c value here, equation, plug in the x value into that, negative 0.6, and solve for c. So we found the y and the c values that produce that function. All right, so try number 8. And now you're ready to check your work for this. So all the steps for this will be revealed. Make sure you pause the video, take a look at everything carefully, and understand what's going on. The work for part D is up here. Study this carefully. Basically, we were solving for x here. Then that was plugged into or substituted into our function here for this x right there. And then we went on to find the derivative. And then we followed the steps similar to the other problem. Again, study this carefully. And there's one more problem, 9. I'm running out of time in this video. I will reveal the solution, pause it, and study it. All right, check your work, pause it, study that.